So to begin with, remember, our test is moved up, and I checked with my colleagues, and almost everybody is testing on Friday because they feel like this unit is pretty easy, and I hope you feel the same way. So remember what these guys look like? The parent graph of this and the parent graph of that, and that I call the volcano, and this I sometimes call it the butterfly, because if you look at it and you kind of squint and you imagine that there's like a little head on this end, you see how these are like its wings? Anyway, the butterfly and the volcano. So what are we doing to them today? We're just simply putting a 2 out front, which then goes on top. Think about that. If you multiply by 2, you don't multiply by the 2 on the top and the bottom, because that's multiplying by 1. Do you get what I mean? It's not 2 over 2, it's 2 over 1. So do you get multiplying in front actually puts it on the top? Does that make sense? So if I multiply by 2, I'm really multiplying by 2 over 1, which really puts a 2 up there. And what does it do? It stretches it. But honestly, it stretches it in such a way that you can't even tell that anything happened. Like if we looked at this graph and I put the stretch in there, this line might be a little sharper, but otherwise the turn is a little sharper. That's it. So you almost can't tell the difference that you've stretched it. So when it really shows up is just in your list of points, because if you have 2 over x squared, you'll obviously get different answers than if you had a 1 over x squared. So in your xy chart, you'll just have a slightly different what? Y value. Because see, y equals, and if this is a 2, it's twice as big. Okay, so, but when I'm telling you, when you look at the curves, you can't barely tell any difference. So that means today is super easy, because it's the same stuff over and over again. It's just that now when you find your xy chart and there's 2 over x squared, you'll get slightly different points. Will your x's be different? No. Remember my advice, always find the thing that makes the asymptote, like in this case 0, and then if I stick a 0 in here, it'll be the asymptote. And then find something on the left and the right of it, which would be like -1 and 1. Would you please just give me those 2 answers? Because if you can find these points, I'm confident you'll be able to find the asymptotes, and that'll be easy. So you're sticking -1 in the function. And you're sticking 1 in the function. And if you're smart, you'll realize it's the same thing. You know what I mean? Like if I put in a -1 right here, or if I put in a 1 right there, it's going to be the same thing. Because when you square it, you get the same exact thing. So it's either 2 or it's 2. They're identical. So then you graph it. But wouldn't it be nice if you had the asymptotes? It would. So you go horizontal asymptotes, do the 1000 trick in your head. Vertical asymptotes, that's the thing that makes the denominator 0. Would you take a second and please figure out the horizontal and the verticals for this? And that's an x. Horizontals, 1000 trick. Verticals, what makes the bottom 0? And in this case, they're both 0. It seems weird. But if you have 2 over a million, 2 over a million is pretty much 0. So you got y equals 0. And the verticals are what makes the bottom 0. What makes the bottom 0 is if you put in a 0. Asymptote, asymptote. These points, -1, 2, and 1, 2. Now let's just analyze if this hadn't been stretched. What would be different about it? I'll show you. If it hadn't been stretched, it would have gone to there and there. It would have been 1, 1 and -1, 1. And look at the difference in the graph, the black one versus the blue one. You see why I say it almost doesn't make any difference? So there's a tiny difference, and it's in the points on your table, because there'll be a 2 there instead of a 1 there. Okay, there's the big picture. I feel like I could just be done, but let's just analyze a little bit more about the stretching. What if there's a 3 there? Well, take a second. I bet you in 1 minute you can figure out the horizontal, vertical, and graph it. Then we'll take a minute to remind you how to do limits, because if you forget that, you're going to probably get a B on the test where you could have had an A. Limits are all over this test. Bontheus, talk me through the horizontal asymptote. Act like I am your friend who doesn't know how to do this stuff at all. You put in 1,000 for x, okay. 3 over a million, which is what? Basically 0. So since it said y equals 0, there you go. Cool. And go ahead. Can you tell me the vertical one now, Ryan? Pontius, do you know how to do the vertical? So, how do you know that it's 0 though? Like what do you do to figure out the vertical asymptote? Whatever makes the bottom 0. There you go. All right, good. Now I can graph those. And then we need an XY chart. Addie, can you tell me something that you chose to put in for X that would be smart? 0, because it makes the, all right. And then you can just put in a number on either side of that asymptote, like -1 and 1. -1 and 1 are going to act the same because we're squaring it. So it's 3 and 3. -1, 3. 1, 3. And that is so close to what it would have been if I had had no stretch. If it would have had no stretch, it would have just gone to there instead. So it's really, really close. The lines would have still had to go towards the asymptotes. All right. Okay. This is too easy. Skipping that one. Going to this one. Okay, this is a pretty typical test question. Let's see how you do on this one. It's been stretched and it's been moved, and all you do is do the asymptotes the same as always. They're a little trickier. And then you make me an XY chart. See if you really got this. Because if you really got this, we can be done. Literally, like 8 minutes into class, we could be done, and then we'll do a little bit more top 20 stuff. Actually, we're going to go back and do first 20, I think. But we'll do a little more top 20 this week. Then next week, we'll do first 20. And then you will be so good at your basics, you'll be unstoppable. Trent, walk me through the horizontal asymptote thing.
Put 1,000 where X is.
Okay. And then is 1,000 minus 1 pretty much 1,000? What's 2 over 1,000 pretty much?
Pretty much 0.
And then you add 4.
So it's just y equals 4.
Y equals 4. You are correct, sir. Wait, dang it. I just did a vertical asymptote at 4. Oops. Horizontal. You know how I caught that? Is I saw the word horizontal and I went, wait a minute, that's not a horizontal line. There, that's a horizontal line. Okay. TiVo, how do I find the vertical for this one?
Whatever makes the bottom 0.
What makes the bottom 0, which is?
1.
1. And then if you just write 1, I will cry a little bit and mark it wrong. So what should you write?
X equals 1.
X equals 1. Perfect, because it's a vertical. The X kind, I call it zertical. And then that's at 1. And then it's all about this chart. I said if there was only one thing that I could bless you with for this unit, it would be, can you find points? Because you could even forget how to do the asymptotes. And if you had enough points, you could figure out where the asymptotes are because of how it curves. So points. Mr. K, can you tell me what I would argue is the most important point to find? If you stick in 1, you get the asymptote, and therefore I agree, it's the most important spot. Because then you can go on either side of it, which would be 0 and 2, good. And everybody, if you haven't already, you got to stick 0 in the function, and then stick 2 in the function. All right, if I stick in a 0 here, I get 2 over -1, which makes -2, plus 4 is 2. Anybody else get 0, 2? Good. Claire, sorry, I got so many Claires, and now you're Clara, my bad. So Clara, can you tell me what you got when you stuck a 2 in?
A 6.
This came out to 2 plus 4 is 6. And now, the last part, I mean, everybody knows how to graph points. If you don't, you probably have failed every graphing test. So I bet you know how to do that. Over 0 up 2 is there. Now, I could see getting confused, but, you know, generally you should know how to graph points, right? And then over 2 and up 6. And now you have to focus in on the rules for asymptotes is that this gets closer and closer and won't touch, and this gets closer and closer and won't touch. And this will get closer and closer and won't touch, and closer, closer, won't touch. There you go. That's all there is to it. Do you get, if you wanted to find more points, they would be on these lines. It'd just be a kind of a, you know, tedious process to find more and more points, and they'd be all decimals. So, if you need more points because you're confused about where to draw it, make more points. Just make more points on the table. Pick more things that are, you know, near, hopefully near the asymptote, somewhat near the asymptote at least. So for example, if I wanted to put in 3, I'd have 3 minus 1 is 2, and then 2 over 2 is 1, plus 4 is 5. 3 comma 5 should be on my graph. And look at that, I almost hit it exactly right there. That's 3 comma 5. Okay, so do you feel like you understand rationals? If I give you a problem like this, it's different than all the other ones we've graphed. Can you still tell me the horizontals and the verticals? And if there's a hole, because the whole thing could really mess you up. Okay, now some of you trying to do this without factoring, oh, it's going to be way harder. Mason, can you tell me how to factor that bottom thing?
Oh, yeah, X, plus 4 minus 1.
Yes. If you were trying to do the 1,000 trick without that, you would really get confused. But if you do it with it, then the horizontal all of a sudden is pretty easy. The vertical, also easier. Because you might have thought 4 was the only vertical, but look, there's 2 things that make the bottom 0. Okay, so the horizontal, it's the 1,000 trick. It's, remember what we're really doing there is we're saying, oh, we put in 1,000, we're going way to the right. And we're seeing if it like leveled off somewhere, like is there an asymptote somewhere? And that's what the 1,000 trick really does. So 1,000 here is about 1,000, and this is about 1,000. And so it's 1,000 over 1,000 times 1,000. I would cancel off one of them, leaving about 1 over 1,000, which is pretty much 0. The verticals, what makes the bottom 0? X equals 4, x equals -4. Was there a hole in this case? No. Do you get if there had been like an x minus 4 on top, there would have been a hole? And this is important. That means it wouldn't have been an asymptote. You know, like we say whatever makes the bottom 0. This is weird because it makes the bottom and the top 0. That makes a hole in the graph. So let's investigate that a little more. So here's like the hardest kind. It has a hole in it. You ready? Find the vertical, and sometimes there's more than one vertical asymptote. Find the horizontal. And if there's a hole, figure out where. Hint, the x value is just part of it. Let's say you figure out the x value is 8. It's not, but let's say you did. You also got to figure out what you get when you stick 8 in the function. In other words, f of 8 goes right there. See if you got this. So this is like your final test on this. Can you take this one, figure out its horizontals, figure out its verticals, figure out its whole, and not just the x of it, both parts, and then sketch it. Okay, let's see how random person did. Dice of Destiny. Who's going to talk me through the first part, and then I'll switch it up amongst like 6 people. Row 1, last person. Pontius, it likes you today. What is the first thing to do on the problem? You start this and you do what? Factor. Nice. So factor it for me. And I'm just going to move the y over. And what do you get? Correct. Bottom? Perfect so far. Next person is row 2, person 3. Nunez, that's you. What do you say we do after we factor it? Hint. Notice these. What do you do to them? You do cancel them. And then right away you go make the whole, which is 4, because that's what makes this part 0. And what do you do with the 4 to get the other part? Yes, here. Because the other part would just make it cancel, or make it 0, and we don't want that. So we put it in just this part. Final answer? 5 ace is correct. All right. Next. Arrow, it's you. Tell me how to do the horizontals. Thousand, pretty much 1,000 over 1,000. Y equals 1. Okay. Row 1, person 2. Mason, that's you this time. The verticals.
X equals -4.
Yes. What if the kid next to you said, well, the other thing that makes the bottom 0 is +4? What would your argument back be?
I'd tell him that would be the whole.
But you're right. Can't use that because it's actually a hole. It's not a vertical asymptote, it's a hole. Okay. Now over on the XY chart. Claire, that's you. What is a smart thing to put on your XY chart? There's more than one right answer for this. I agree, which is what?
-4.
So I'm putting in a -4, and I already know that's the asymptote. Very good. Then that gives you the clue. We should probably put in something on either side of that, right? So Claire, give me something on either side of it.
-3, -5.
Nice. Okay, next person. Claire Gilbert. What should I get when I put in -3 into, I'm going to clean this up because it's simplified to x plus 1 over x plus 4, and you put in the -3, and what do you get? Double checking it, you have -2 on top, and 1 on the bottom, so -2 is correct. And then we put in the 5, and a G. What'd you get when you put in the -5?
4.
Double checking you, it's -4 over -1, which makes +4. Very good. Okay, one more thing, and this is important. Did you remember it? Did you put the hole on your graph? A lot of kids forget that. You said what the hole was, but did you put it in on the graph? So if I were you, I'd go make, in my list of points, I'd add one more, which is the hole. If you don't include the hole in your graph, you lose points. And I know you might not know where 5/8 exactly is, but 5/8 is pretty much 4/8, which is pretty much a half. So 4 comma a half would have been good enough for the graph. All right, so now I'm going to graph these things. First, I'm going to graph my asymptotes. Horizontal one, y equals 1. Horizontal is like the horizon. Vertical, -4. -3, -2. It's down there somewhere. -4 is the asymptote. I already got that one. -5 is 4. That's up there somewhere. Now, it'd be so tempting to just go like this and go like this and be done and forget the hole. I bet some of you did that. The hole is at 4 comma 5/8. So here's where 4 is. And 5/8 is like, I'm not sure exactly where, but it's not very big. It's 5/8 is about a half. So you go put an empty spot right there. And your graph goes through that. I will be looking for that hole. Your test will guarantee you there'll be a hole. And you'll have to put it on there. And if you don't, the whole problem's wrong. It'd be so painful to have asymptotes right, lines right, but you didn't actually put the hole in. Be honest, how many of you forgot till I said to put it on there? Be honest. All right, that's like 7 of you. Thanks for being your honesty. If you remembered, way to go. You'll probably remember on the test. Okay, I think you've got this. So, one last worksheet, and let's start it together. So everybody find the worksheet that's posted for today. We'll do the first couple together. I'll tell you to skip some. And then we'll take a minute for top 20, like most missed questions. Just to look at it, not to check up on you, but I want to know which ones I should skip. Can you scroll up a little bit? And up a little bit? Man, there's a lot of them. All right. So I think we're just going to do the evens. Just the evens. Now, if you want to do the odds, go ahead if you need the practice. Number 2. Dominic, read me problem 2. 3 over x squared minus 2. Is the minus 2 in a parenthesis with the x? Like, oh. Okay. So it's like this, and then the minus 2 is out there. Okay. So, what does it want? Like, what's the point of the question? We're going to do limits on this too. All right, so that'll be good to practice. All right, so the horizontal asymptote's the first thing I'd do, and that's the 1,000 trick. So Dominic, can you tell me the 1,000 trick? What do we get? And then this is pretty much what? And so final answer, y equals? No. Then you gotta subtract 2. It's 0, but then it's 0 minus 2. So it's y equals -2. I see how that could happen. Really easy. Do you get it? Do you get what I mean? Yeah, there's this minus 2 here. You gotta include that. Okay, then the vertical asymptotes. It's whatever makes the bottom 0. Rissy, what do you get for the x vertical asymptote? 0 is correct. And you don't have to include the 2, because once this thing doesn't work, that's the asymptote. It doesn't matter if you subtract 2. It's still, the asymptote is whatever makes the denominator 0. All right, now I go over and I start graphing this thing. And I have the asymptote at, the vertical one is up and down. That's like this. The horizontal one is like the horizon, and that's like this. Then I need a few points. If I had an XY chart, I'd start with the asymptote, where it was 0 was the x, and then that was the asymptote. And then I'd go on either side of that. And now I'm going to put in a -1. And that becomes 3 minus 2, because of that. 3 minus 2 gives me 1. And I'm smart enough to know that the regular one will act the same way because, you know, the negative squares away, so it's also 1. So now I can go to -1, 1, and 1, 1. And was there any hole in this thing? Nope, there was nothing that canceled on the top and the bottom, so there's no hole. So then I can just say it goes kind of like this. Closer and closer to the asymptotes. Closer, closer to the asymptotes. That's it. Now I got to do the limits. Can you tell me, Tully, what does it say about the limits? Does it say it wants like all 4 limits? Does it say all 4? Okay. Okay, so here's the right end. Here's the left end. Here's the left side of the asymptote, and here's the right side of the asymptote. Those are the 4 limits you got to write. And if I were you, I'd just zoom in and write them kind of small right near them. Limit of the function. X is approaching. Well, remember, if you're riding on this like a railroad tracks, X is getting closer and closer to, well, it keeps going towards infinity. The Y is getting really close to this red dotted line, which is the horizontal asymptote, which is right there. So it's getting really close to -2. And since it won't actually touch it, we don't need to say equals. We can just say an arrow there. I would also accept an equals. You just never want to say equals infinity, because you can't be at infinity. All right, now I'm going to go do the other end. Limit of the function. X approaching -infinity, and the Y value is approaching -1 again. Nope, 2. Sorry, -2. Then up here, always, ever, every single time, limit of f of x, x approaching. Now, as I ride on this rail, the x is getting closer and closer to 0, but it's coming from the negatives. Did you remember that little raised exponent thing? I'm going to highlight it right here. So easy to forget that. And the y is approaching infinity. Then, right side of the asymptote, lim of f of x. As x approaches, I'm riding on the rail here, x is getting closer and closer to 0 from the positives, because that's the positive side of the x and y axis. And the y is getting closer to infinity. So there's a reminder of how these work. We're just doing the evens for today. So that probably took me like, I don't know, 4 minutes. So you'll get faster too, because you won't have to explain everything you're doing. You just have to do it. Problems 2, 4, 6, 8, and I think there's 10. Anyway, so 5 questions. I already did the first one. Lazy 4 questions. I think that's very doable. That's all I have for the video for today.